Hello guys, welcome back to my channel Gamma Die Gamma. Today I'll be doing the topic of tangents and normals because since the exams are near and people requested me to cover this up urgently, so I'll be doing that. So basically, uh, if you see my derivative videos, you might know that once you have the the derivative written like this, dy by dx, this is basically a function, but when you plug in the values for x and y, say a comma b, a point, into that, you get the slope of the tangent at the point a comma b. So that's to say, if you have say an arbitrary curve, this is your point p which has coordinates a and b. Well, the tangent line passing through this line, this line slope would be given by, say this is f of x, the function will be given by the derivative of the function, whatever, say, say you get like a polynomial function. When you plug say a instead of this x and b, if we have a y, if we plug that in, the numeric value that you'll get will be the slope of the tangent line at that point a comma b. Let me give you a more concrete example. Say you have the function y is equal to x cube minus x plus 1. Just an example. So when you differentiate this with respect to x, you get 3x squared minus 1, using the rules that I talked about in the last derivative video. And now, say this is my function, and this is the point P. Say I'll just define the x in this case, because even the derivative is in x, only in x. So so we can draw a tangent line over here. Now the slope of this line is given by dy of dx, dy over dx at that point, say x is equal to 2. That's the slope of tangent at 2. And now you can just plug this 2 in this equation above. You get 3 times 4 minus 1, which is 11. So this tangent line would have a slope of 11 at x is equal to 2. If you want, I'll just repeat this one more time. You have a function y is equal to x cube minus x plus 1. You differentiate that with respect to x, you get 3x squared minus 1. Now this is a general slope function. You need a specific point at which it will output the value of the slope. So say in the question it was told to find the slope at x is equal to 2. Then you plug 2 in the place of x. So 2 square is 4, 3 times 4 minus 1 is 11. So the slope of the tangent line at 2 is 11. Let's do some questions now. And eventually, if you didn't understand, you would understand after doing these questions with me. So you have y is equal to x cube plus ax plus b, and they say in the question that the tangent at point P which has coordinates 1 comma minus 6 is parallel to the line y minus x plus 5, which you can again write as y is equal to 5 plus x. Now you should know that if two lines are parallel, then that implies that m1 is equal to m2. Both lines have same slope. So if the tangent at this point is parallel to this line, then the slope of the tangent should be equal to the slope of this. So slope of tangent should be equal to slope of y is equal to 5 plus x, this equation, this line. Now you can, for the slope of the tangent, you might want to differentiate this. So we can go ahead and do that. Dy over dx is equal to 3x squared plus ab is a constant, it goes away. But they're telling the tangent at point P, so you need to plug the information of x and y into that. So the slope of tangent at 1 comma negative 6 is just dy over dx at that point 1 comma negative 6. You can plug the value 1 in place of x. There's no y, so negative 6, there's no place for us to plug that. 3 times 1 squared is 3 plus a, so 3 plus a. Now this should be equal to the slope of the line. So slope of y equals 5 plus x is 1, because this is of the form y is equal to mx plus c and m is 1. So slope of, or you can just take the derivative and you'll get 1 in any case. So slope of this line is 1. So basically that's to say that 3 plus a is equal to 1, because that's what we said earlier. So a shall be negative 2, but since we were finding tangent at point P and point P lies on this curve y, otherwise it won't make any sense to have a tangent line any place, right? I mean, a tangent line is basically that's touching the curve. So the point at which they've asked us to find the tangent line, and basically that point should lie on the curve too. So this point lies on this curve, so you can plug all the values in this equation and they should satisfy this equation. So you have negative 6 is equal to 1 minus 2 plus b, which means b is negative 5. So there we have it. We found the values of a and b. You may want to write the function properly again. X cube minus 2x minus b. That was your original function. Before proceeding, I would just like to tell you guys that if a line is parallel to the x-axis, then its slope, or dy over dx, will be equal to 0. And if a line is parallel to the y-axis, then its dy over dx would be infinity. Just these facts, because in the question they might not give you a numeric value, they'll just say that the tangent is parallel to the x-axis, then you have to make this assumption. Now in this question, the next question, it's told us to find the equation of tangents and normal at the point 80 squared comma 280 on the curve y square is equal to 4ax. Now let's go ahead and differentiate that, find our dy over dx, and then we can get our tangent, the slope of our tangent at this given point, and we plug that in. So let's differentiate 2y dy over dx is equal to 4a. Hope you know what I did there. Just some implicit differentiation. Dy over dx is equal to 2a over y, and you can go ahead and find the slope of the tangent at this point, plugging the information of this point. So 2a over y, and y is 280. 2a cancels out. We are left with 1 over t. That's the slope of the tangent line at this point. So we have our point and we have the slope. We can find the equation of a tangent line by using the point slope formula. Y minus the y value of the point is equal to the slope times x minus the x value of the point. So I'll just probably clean this up. X over t minus 80 plus 280 is x over t plus 80. Anyway, this is just algebra. And now for the normal, this is a new concept. We must first know that if you have a curve, an arbitrary curve, you have the tangent at this point. Sorry if the tangent is imperfect. You have the tangent at that point, say a comma b. Then the normal is always perpendicular to the tangent. So if the slope of the tangent is m1, then let m2 be the slope of the normal, which the negative reciprocal of m1. Hope you know the perpendicularity conditions of lines, same thing. So, but we know that m1 is in every case dy over dx. I'm just writing a general, I'm not mentioning the point for now. So m2, or the slope of the normal, is negative dx over dy. Basically you have dy over dx, you flip it and add a negative sign. And in our example, slope of the tangent is 1 over t. Slope of tangent at 80 squared comma 280 is equal to 1 over t. So basically the slope of normal at the same point at 80 squared comma 280 is basically flip this and add a negative. So when we flip this, we have t and a negative, so negative t. And you can now use the same point slope formula to find the equation of the tangent. Now we know the slope. The point remains the same. Because the tangent and the normal are perpendicular at a particular point. In this case, 80 squared comma 280. So y minus 280 is equal to negative t times x minus 80 squared. Now y minus 280, if I take the negative in, I flip this expression. So 80 squared minus x, y is equal to 80 cube minus xt plus 280. That's the equation of your normal. Equation of normal at that point, at this point. Now let's do a parametric example. So they're telling us to find the equation of tangent and normal line at theta equals pi over 4 of the set x is equal to a sine cube theta and y is equal to a cos cube theta. Now before doing anything we need the point in the form x comma y. You might want to do that now. So because we need that for to use the point slope form, we need a point. So the given point is we can just plug in your theta over here. So it's 1 over root 2 cube comma a times 1 over root 2 cube. You can simplify this. It's a over 2 root 2 comma a over 2 root 2. This is your the coordinates of your point. Now you want to differentiate. You want to find the dy over dx. But we have everything in theta. So what we're going to do is we're going to differentiate y with respect to theta, x with respect to theta, and divide them like this. So okay, let me do that separately for now. So dy over d theta is 3a cos squared theta. Because of the chain rule, you have a negative sine theta. The derivative of cos theta is minus sine theta. And dx over d theta is 3a squared. Sorry. It's 3a sine squared theta cosine of theta. Now we want to go ahead and divide both of them. So dy over dx is dy over d theta upon dx upon d theta. Now that will just be minus 3a cos squared theta sine theta over 3a sine squared theta cos of theta. Sine and this power will cancel, this and that. We are left with negative cos theta by sine theta, which is famously known as negative cot theta. And now you can find the slope of the tangent line at theta is equal to pi over 4. You can just plug that in. Negative cot of pi over 4. Cot of pi over 4 is 1, negative 1. Okay, and then now we have the x and y point, and we can find the equation of tangent. y minus a over 2 root 2 is equal to negative 1 x minus a over 2 root 2. As the equation of the tangent. You can clean this up and shit, but I'll leave it as an exercise to the viewers. And since we know the slope of the tangent line at theta is equal to pi by 4, you can also find the slope of normal at theta is equal to pi by 4. Just flip this and add a minus. When you flip this, it's 1, and then when you flip this, sorry, it's negative 1, and then you add a negative, it becomes a positive 1. So we can write the equation of normal y minus a over 2 root 2 is equal to 1 times x minus a over 2 root 2. Yes, you might say that this and this will cancel out eventually. Okay, y is equal to x. Simplification is easy anyways. So yeah, we have the equation of the tangent, we have the equation of the normal. We're done. Now many of you had problems calculating the second derivative. So d2y by dx squared is nothing but t over dx of dy over dx. You have an expression for dy over dx, but the problem is d over dx, since everything is in theta, you need to first differentiate dy over dx with respect to theta and then divide that by the derivative of x with respect to theta. And we already have the expression for dx over d theta. We just need to differentiate this negative cot theta one more time. So negative cot theta is being differentiated over here, and in the bottom we just have 3a sine square theta cos theta. This wasn't asked in the question, I'm just doing this because many people had doubts. The derivative of cot theta is negative cosec square theta, and that negative, this negative cancels out. So cosec square theta over 3a sine square theta cos theta. You can write this cosec square theta as 1 over sine square theta. That sine square theta goes in the bottom, becomes sine to the 4th of theta times cos theta. Yeah. So basically this is how you do it. You have a first differentiate the dy over dx that you obtained with respect to theta, because even that was in theta, and then divide that by the derivative of x with respect to theta, basically your dx over d theta term that you would have already obtained. This is just food for thought, revision if you will. Now we will do the last easy example. We need to find the equation of tangent line that's tangent to the curve y is equal to 4x cubed minus 3x plus 5 and is perpendicular, the tangent is perpendicular to the line 9y plus x plus 3 is equal to 0. Now we all know the perpendicularity condition, right? You just need to, basically you have two lines whose slopes are m1 and m2. The product should be equal to -1, or you can just say that m2 is equal to -1 over m1. So you flip m1 and add a negative sign as we discussed before. So we can go ahead and find dy over dx. We don't know the x and y coordinates at which to find the tangent line. We have to find that. So dy over dx, we differentiate this, is 12x squared minus 3. Fair enough. And perpendicular to this line, we can find the slope of this line. So 9y is equal to negative x plus 3 in brackets. So y is minus x by 9 minus 1 by 3. So the slope is minus 1 by 9. So slope of tangent at whatever point that we have to find is basically, you flip this up because they are normal, so you need to apply this. So you flip this up. So say m1 rm1 in this case is negative 1 over 9. You flip this up, you get negative 9 and then add a negative, so it becomes 9. Slope of tangent, and we have dy of dtx. We know that these two are equal. 12x squared minus 3 is equal to 9. 12x squared minus 12 is equal to 9. In 12, we can take the 12 common outside. X squared minus 1 is equal to 0. You can divide both sides by 12. You'll have x minus 1 times x plus 1 is equal to 0. So we have the two possible x values of the points which will satisfy the condition of the question. So we have x is equal to 1 and x is equal to negative 1. You can plug that in the original y. Y is equal to 4x cubed minus 3x plus 5, which was our original curve. 4 times 1 cube minus 3 times 1 plus 5 will evaluate to 6. And this is when x is equal to 1, and this you can just substitute a y again in the equation. So you have 4 times negative 1 cube minus 3 times negative 1 plus 5, which will evaluate to 4. So the 2 points that will satisfy the condition of the question are 1, 6 and negative 1, 4. The basic, so that's to say that the slope of the tangent lines at these 2 points would be, that's to say that the tangent lines at these 2 points are perpendicular to the line 9y plus x plus 3 is equal to 0. So tangent lines are perpendicular to this line. You can graph it up if you want, if you don't believe me, but math works. So but the last question is challenging, and I would say is an ultimate question. So we told us to find all the points on the curve y is equal to 4x cubed minus 2 times x to the 5th, at which the tangents pass through the origin, which for some kids is 0 by 0, 0, the point 0, 0. So you can go ahead and find the slope of the tangent line as we always do. So it will be 12x squared minus 10 times x to the 4th power. So you can take an arbitrary point now. You have a curve like this. Take an arbitrary point p x comma y, x1 comma y1. Okay, because it'll be confusing otherwise. X1 comma y1. So the slope of the tangent line at that point px1 comma y1 is obtained by basically plugging in this information. So 12x1 squared minus 10x1 to the fourth power. And the tangent is going through this point. Then this point is basically satisfying the condition. So in the end we need to solve for x1 and y1. So since we know the slope at that point and we know that point, we can use the point slope formula. Y minus y1 is equal to 12x1 squared minus 10x1 to the fourth power, everything times x minus x1. That's our equation of the tangent at a point x1 comma y1 which satisfies the condition of the question. That's the equation of the tangent line. And they've said that the tangent line passes through the origin. So basically this equation should the point 0 comma 0 should satisfy this equation. So you can just plug in x is equal to 0 and y is equal to 0. So when y is equal to 0, you have negative y1 is equal to 12x1 squared minus 10x1 to the fourth power, everything multiplied by when x is 0. So you have negative x1. You can just cut out the negatives here. So y1 is equal to 12x1 cube minus 10x1 to the fifth power. But let me remind you that this point p x1 comma y1 at which we are to find the tangent, at which we found the tangent that satisfied the condition of the question. This point also lies on the curve, so you can plug x1 comma y1 into the equation of the curve. So let's go ahead and do that. Our curve was y is equal to 4x cubed minus 2x to the fifth. We can just plug x1 and y1 in this equation. So y1 is equal to 4x1 cubed minus 2x1 to the fifth power. You have y1s equal to two different things. So you can say finally that 12x1 cubed minus 10x1 to the fifth is equal to 4x1 to the third minus 2x1 to the fifth. Now it's just algebra, so we have 8x1 to the third is equal to 10 minus 2 is 8x1 to the fifth. I can just move things here. 8x1 to the fifth minus 8x1 to the third is equal to, you can factor out the 8, and x1 to the third is equal to x1 squared minus 1 is equal to 0. So all possible x1 values are x1 is equal to 0, 1 and negative 1. You can find the y1 values, corresponding y1 values, by using this equation, because we have anyways two equations for y1. Use any one you want. So you will get 0 when x is 0, 2 when x is 1, and negative 2 when x is negative 1. You can plug it in and check for yourself. So the points at which the tangent line passes through the origin, as the question demanded, the points are 0, 0, 1, 2 and negative 1, negative 2. Again, you can graph it up, but math works, always has been working. So I hope my video gave you a good intuition, more than intuition, let's say some practical understanding of how to solve or approach these kinds of questions. Basically, what you do is, if they tell you to find tangent, you find dy over dx. If they tell you to find I wanted to say tangent, and if they tell you to find a normal, you again find dy over dx and just flip it up to negative dx over dy, and sometimes they'll give you a point at which you can obtain the slope of the tangent. Sometimes you'll have to find the point. They'll say tangent is perpendicular or parallel to a line, and you can use uh, the information. So when lines are perpendicular, their slopes are equal. If if lines are parallel, their slopes are equal. If lines are perpendicular, then you have this relation m2 is equal to minus 1 over m1. You can basically flip the first slope and then add a negative there. So to keep in mind these things. In any case, you have to find dy over dx, and work in the most logical and natural manner. It's easy, guys. Trust me, you'll get it once you solve some questions by yourself. I hope you enjoyed this video. Please like, share, and subscribe. And have a great day. All the best for your exams.